Hello and welcome to Math 65, talking about Introduction to Polynomials. And there is a little typo here, so this is only 2 pages. You're not missing some pages, so 1 of 2, and this is 2 of 2. So just one little correction. So far, we have studied one type of function, linear. There are functions which involve numerical multiplication, addition, subtraction from a variable x. Oh, those are functions. These are functions. Now that we know a bit more about exponents, we'll introduce new types of functions, polynomials. And then, by the way, when you get to Math 111, you do a lot more with polynomial functions. So we're just getting an introduction right now to polynomials, and we need some definitions. So the definition of a term is the product. Now, what does this word product mean? It means multiply. The product of a number or one or more variables. So an example of a term could just be 5 just by itself, or 5x, or 5x squared y cubed. That would be a term. Even 1/5 x, a, b, c. Although we would never write it like that, we would write the x in alphabetical order. A polynomial is a collection of terms combined through addition and subtraction with only positive whole number exponents. Whole numbers, the whole numbers are 0, 1, 2, 3, ... So we have to have positive exponents, and they need to be whole numbers, not fractions. So we can identify polynomials and distinguish them from other types of functions. Which of the following is a polynomial? Is this a polynomial, x plus 3? Any thoughts? Yes, it actually is a polynomial, and that's because x is to the first power. That's a whole number, okay? It has addition. Actually, what separates terms is addition and subtraction. Now, why can't I add x and 3 together? Yeah, they're not like terms. Exactly. Here we have 3x to the second power minus 5x plus 8. Yes, this is actually 1, 2, 3 terms. In a moment, we're going to talk about what that's called, but this is a polynomial with 3 terms. So this one has 2 terms. This one has 3 terms. What about this one here? Is this a polynomial? Why is it not a polynomial? Yes, so when we're dividing by this variable, this would be the same thing as 8x to the negative 1 power. Does everybody get why that would be the same thing? Who can explain why? Yes, invert the sign. So that's the reciprocal. That negative 1 does not count as a whole number exponent, so therefore this is not a polynomial, okay? Now this one is a little bit tricky. Anybody know if this one is a polynomial? It's not a polynomial. Why is it not a polynomial? Yes, you already know that this is a fraction. So this right here is the same thing as 3x to the 1/2. We haven't even learned about the 1/2 exponent yet. You will learn about that in Math 95 and Math 111. But just trust me right now, when you have the square root of x, that's the same thing as having x to the 1/2 power. So the square root of x is equal to x to the 1/2 power. Is the 1/2 power, is that a whole number? No, 1/2 is not a whole number. So that makes this not a polynomial. So we have 2 polynomials and 2 non-polynomials. Now, polynomial is just a big umbrella term. Polynomial is the umbrella term, and then there's more specific. Poly means many. Nomial probably means number, something like that. Okay, but we can be more specific than that. If I have only one term, what is the name for one term? monomial. Okay, what's the polynomial that has two terms? Binomial. Bi means two. Bicycle has two wheels, right? Trinomial. 3 is trinomial, just like a triangle has 3 sides. Okay, classify each polynomial with the number of terms. So how many terms is this? 3 times x squared. This is a monomial. Monomial because it has one term. Since they're all multiplied together, there's no addition or subtraction. It's all multiplied, okay? And this is a positive 3. What about this one right here? This is a trinomial. Trinomial. And the last one must be a binomial. Okay. The degree of a polynomial is the largest exponent. So let's go back to these for a minute and let's look at the exponents. And then, by the way, also the leading coefficient of a polynomial is the coefficient of the term with the largest exponent. So let's just look at these examples for a second, and then we'll go to these other ones down below. What's the degree of this polynomial, of this monomial? Yep, degree is 2. What's the degree of this one? Degree of 2, and this is the leading coefficient, is 5. What's the degree of this one? Degree is 3, and this would be our leading term. The leading coefficient is 5. Okay, now we're going to do the exact same thing down here. Classify the following polynomials by degree. Who can tell me the degree of the first one? Yes, degree of 3. Now, what we're going to want to do is we're going to want to put it in descending order. So if I always want to write my polynomial with the big guy going first so that he is really leading. The leading coefficient is -4. So can I write it like this? -4x to the third plus 3x squared plus x? Yes, I can. That's the same thing as writing it in descending order, okay? Leading coefficient is -4. What's the degree of the next one? Degree of 6. Okay, let's put the big guy in front. 2x to the 6. What would come next? Yep, plus 5x. So I'm putting them in descending order. Here's my leading term. Here's my leading coefficient is 2. And what's the degree of this one? Degree of 1, because x to the first power. What's the leading coefficient? Yes. Does that have anything to do with the degree? No, because there's a 1 there as well. Remember, there's also a denominator of 1 if you want as well. Okay, so there's all those implied 1s. Questions on this before we turn the page? Okay, I'm going to turn the page now. We will often want to write, see, I always tell you these things before I tell you. So we will often want to write the polynomial in descending order based on the degree of each term. Just write the highest degree first, the next highest second, etc., until all the terms are accounted for. When a polynomial is written this way, it is easier to identify the degree and the leading coefficient. Write the polynomial in descending order and then identify the degree and the leading term. So this is what we literally just did, the exact same thing on the previous page. Who can remember how would I rewrite this? It's equivalent. By the way, this is not wrong. This is just using our properties. You know, we can really write it in any order, but proper form, standard form, is to write it in descending order. So what one would you put first? And notice that negative comes with the number, okay? And then what comes next? Yes, plus x. The degree of the whole polynomial is decided by the big guy. Leading coefficient is? Perfect. Okay, let's try this one. What's this one going to be? Yes, plus 5x. Okay, the degree is? And the leading coefficient. Okay, you might want to pause the video and try this, but we're going to keep going. Anybody want to tell me what is the order here? And remember that sign, a lot of times people make the mistake, they don't bring the sign with the number. That's a negative. That negative sign belongs to the 5. What's the degree? 9. What's the leading coefficient? -5. Good. Next one. How would we write this in descending order? Minus x plus 4. Does everybody agree with that? Degree is 2. Leading coefficient? 1. Good. To evaluate. Now, the word evaluate does not mean solve, okay? When we evaluate a polynomial, we're going to substitute the value of the variable and simplify the resulting expression. This is the same idea as evaluating a function. So the questions, evaluate the polynomial for x equals -2. So this is the polynomial right here. We're evaluating for x equals 2. What does that mean to do? Yeah, and this is actually the exact same instruction. For the function, instead of, see here, this is just a polynomial. Here, they put f of x, meaning they're calling it a function. Find f of 2 is exact same instructions. So for both of them, I'm just going to write it in the function one first. If I was evaluating this, I'm going to do the exact same thing. I'm going to write 3 instead of x. I'm going to put a 2 wherever x is. -4 times 2 to the 3rd power plus 2. Am I done? I've evaluated it, right? No. What do I do? What do I need to do next? After I plug in 2, I should simplify. Use my order of operations. How do I simplify this first term? 3 times 4, you see I do the 3, I do the exponent first. She got 4 here and then multiply by 3. So 4 times 3 is 12. Here I would have the exponent first would give me 4 times 8. So right here, this is going to be first. This is going to be 8. 8 times 4 is -32 because that negative sign there, plus 2. So basically, I have 14, I owe 32, because this is positive, this is positive. Or I can go from left to right. What's 12 minus 32? -20 plus 2 is equal to -18. So notice I did not solve. This is not solve, okay? This is evaluate. Evaluate means you did not solve for x. You were given x, and you plugged it in to find y. So if we were going to graph this, the ordered pair would be when x is 2, y is equal to -18. Okay, when you find y, meaning you have x, you are not solving. That's a big, just like semantics thing. A lot of times people will say, I solved it, but you didn't solve it because you already knew what x was. When you don't know what x is, that's when you're solving, okay? Okay, these two problems are asking the same exact thing. Either way, this is a function, is the function, and 2 is the x value. So we just plugged in that x. So for the next one, evaluate the following. So we're literally going to take that x equals 2, and we're going to plug it in. We don't have the function notation here, so we're just going to plug in 2. So we have 3 times 2 squared plus 2 times 2 plus 4. We plug in 2 because we're evaluating. Here we get 4 times 3 is 12, plus 4 is 20. Good. Okay, here, B, we have a -3, and this is really important. Notice how you have a negative here. You're going to have negative outside. Every time I'm plugging in x, I'm going to use parentheses. -3 squared, okay? plus negative 3 minus 7. When you have a negative, it's especially important to use those parentheses because a lot of people will get this sign wrong. Who can tell me what they think this answer is going to be? What would you do first here in that very first term? So you couldn't do the negative times a negative as a positive because you actually have to do the exponents first, and there's actually an implied 1 there. So what's negative 3 squared? And then multiply that by negative 1. Negative 9. That's very confusing for a lot of students, okay? Plus negative 3, and then you could even write this as plus negative 7. So I'm getting more negative. Negative 9 plus negative 3 is negative 12. Negative 12 plus negative 7 is negative 19. Okay. That right there is, I'm glad that example exists in here. Okay, so the same thing here. Whenever I have especially a negative and I'm substituting it, I always want to put parentheses. 3 times negative 2 squared plus 4 times negative 2 minus 2. So that's how we're evaluating. Okay? Now, this is another area where a lot of people make mistakes because they'll want to multiply before they do the exponent. But remember, order of operations, I do exponents first. So negative 2 squared is 4. 4 times 3, I'll just write that out. 3 times 4, that's what we get here, plus negative 8 minus 2. So we have 12 plus negative 8 plus negative 2. Now I'm just writing that plus negative. You could write minus. That's just the rule we learned in Math 60 for how to subtract. We add the opposite. It's basically like owing. So I have $12. I owe 8. How much money do I have? Well, if I pay back that 8 from my 12, I only have 4 left. Oh, but I owe still another 2. How much do I have left when I pay off my 2? I got 2 left. Okay, so I'm just lining up the equal signs, showing my work one step at a time. Now, polynomials can have multiple variables. Okay, so for this next one, I see I have an x and I have a y value. So I'm going to go ahead and plug that in. 2 times 2 cubed times negative 1. That all is going into the first term. Notice I'm using parentheses. This is all multiplied. Minus 2 times negative 1, that's xy, plus 5 times negative 1 squared. Any questions about how I plugged in the numbers? Perfect. Let's go on to the next thing. So we're going to go in order of operations. We're going to do exponents first. 2 times 8 times negative 1. Okay, here you could think about this as adding a negative. So a negative times a negative, that's going to be a positive 2. And then what's negative 1 squared? 1. What's 1 times 5? Positive 5, right? What do I get as my first term here? Negative 16 plus 2 plus 5. Yes, plus 7, sure. Negative 16 plus 2 is negative 14. Negative 14 plus 5 is negative 9. Good. Okay, that sums it up. Any questions about that?